Every AI today has the same problem. Ask it a quantitative question and it'll give you a confident answer that might be completely made up. I got tired of it, so I built the fix. This is Aurora. Right now, Claude is calling it through MCP to find the most anomalous trading days for NVDA in 2024. Aurora is computing the answer locally, not predicting, not approximating. Running 8 statistical methods, citing every claim, returning a SHA-256 hashed bundle. Watch what it found. 6 anomalous days, 3 independent detectors. One day, March 8th, flagged unanimously by all 3, 0 fabricated. Now watch the same question in vanilla ChatGPT, no Aurora. ChatGPT is reasoning. It's pulling the file, sorting on return size and volume, then pattern matching to news it remembers about February earnings, March reversals, the supermicro sell-off. Here's the problem. None of those statistics are verifiable. The z-scores aren't shown. The methodology is a paragraph of prose. There's no bundle hash, no reproducibility guarantee, no fabricated _count contract. If you asked ChatGPT the same question tomorrow, you'd get a different answer with different framing, and you'd have no way to verify which version was right. Worse, ChatGPT picked 3 days. Aurora found 6. The 2 it missed, May 23rd and July 31st, were real earnings reactions at a mid-year tech rally that any quantitative anomaly detector would catch. ChatGPT's ranking wasn't a ranking. It was a story. Aurora computed. ChatGPT narrated. That's the difference. Let me show you what this actually feels like as a human user. I'm dropping in environmental buoy data, temperature, precipitation, barometric pressure across thousands of observations. Aurora runs 19 advanced methods in parallel. Hidden Markov regimes, Granger causality, persistent homology, Cindy, Gaussian processes, wavelet transforms. Here's the synthesis. Aurora's local language model is writing this, but it can only use phrases backed by retrieved knowledge entries. Every claim has a seed, citation. If a claim can't be grounded, the verifier flags it as uncertain. You can see one right here highlighted. Aurora explicitly tells you the bounds on this forecast should be interpreted with caution. That's the honesty layer working. The intelligence panel. Top anomalies, ranked by RAW with z-scores. Forecast peak at 1.49 with a 95% confidence interval from negative 2.15 to 5.13. A what-if simulator. A discovered physics model. Aurora picked a logistic growth RMSE 1.586 and checked the dimensional consistency itself. The calculus tile classified this dataset as oscillatory at 80% confidence. Notice this section, learned from past runs. Aurora compared this dataset to 63 past runs with similar calculus signatures and surfaced the priors that matched Newton's law of cooling, damped harmonic oscillators, Pearson-Moskowitz wind wave coupling, real physics retrieved by data signature. The space-time view shows world lines for every variable with future cones. The phase space view, the system graph, 3 different geometric perspectives on the same underlying physics. 11 findings total, 5 critical. Each one tagged with the method that found it, cited to a published paper, Shandola, Granger, Baum-Welch, Vietoris-Rips, reproducible, bundle signed. 0 fabricated. Same workflow, different domain. This is the UCI air quality dataset. 9,000 rows, 15 columns of sensor readings from an Italian city over a year. Cross-sectional data, no time axis, 15 gaps. Real messy environmental data. Notice the load bar. Aurora detected 20 critical tier anomalies before it even finished the deep methods. Confidence, 74%. That's the system telling you up front. This data has structural issues. Here's where I'm certain. Here's where I'm less certain. The synthesis is grounded in 12 knowledge entries. Aurora identified several critical anomalies at specific row numbers, 3,646, 3,647, 3,648, and 6,699, and noticed they share consistent values for ammonia, benzene, and toluene. That pattern matches a known diurnal cycle. Aurora caught it and cited it. Mutual information detected nonlinear dependencies between carbon monoxide and nitrogen oxides, relationships a simple linear model would miss. Aurora used the Kraskov-Stogbauer-Grasberger estimator. Cited. Granger causality found a directional effect. PT08-S1. Carbon monoxide increases drive a positive shift in ground truth carbon monoxide. Polynomial fit, RMSE 127.85. Cited. Here's the pipeline notes section. This is critical. Aurora tells you exactly what it did under the hood. HMM analyzed an 1,817-row stratified sample because the full dataset exceeded the time budget. Wavelet analyzed 2,673 rows. Regime detection was deferred because it hit the 90-second per method limit. Aurora is telling you what it skipped and why. Most tools hide this. Aurora shows it. The intelligence panel. Top anomalies starting at row 3,649, ammonia z-score 448.6. The what-if simulator says if PT08-S1 carbon monoxide goes up by 1, ground truth carbon monoxide rises by 0.008863. That's a learned causal sensitivity. Physics tile discovered a polynomial relationship. Y equals a minus t squared plus bt plus c. The dimensional check confirmed unit consistency. 4,825 derivative sign changes flagged as a warning. The system is telling you the discovered model fits the data, but may not capture all the nonlinear complexity. Honest. Calculus signature, oscillatory at 80% confidence with 19 advanced methods deployed. Hidden Markov says the data is currently in state 1 with 84% posterior probability. Bayesian Bayes information criterion selected k equals 4 hidden states. Bootstrap stability of cluster assignments 0.90 strong. Multivariate outlier consensus 319 of 5,000 rows flagged by at least 2 of 3 independent detectors. 3 detectors agreeing. That's a 20x reduction in false positives over any single method. 11 findings, all grounded, all cited. 0 fabricated. Last demo. And this is the one that shows what Aurora is actually for. Factory machine telemetry. 5 sensors, vibration, G-force, motor temperature, RPM, bearing load. Time axis is real this time. No gaps, no duplicates. The kind of data a maintenance engineer would have on a production line. Aurora's synthesis is now in production incident mode. Critical anomalies impacting equipment health, potential imminent failures, anomalous vibration values at z-scores of 16.6 and 15.9. Coupled with motor temperatures at z-scores of 15.6, 15.1 and 14.7. A regime change to a high state detected with a mean shift to 90. Aurora is telling you this machine has fundamentally shifted operating regimes. That's the kind of finding that, in a real factory, would trigger maintenance. Aurora's synthesis is now in production incident mode. Critical anomalies impacting equipment health, potential imminent failures, anomalous vibration values at z-scores of 16.6 and 15.9. Coupled with motor temperatures at z-scores of 15.6, 15.1 and 14.7. A regime change to a high state detected with a mean shift to 90. Aurora is telling you this machine has fundamentally shifted operating regimes. That's the kind of finding that, in a real factory, would trigger maintenance. Everything you just saw runs locally. Open source, Apache 2.0, the engine, the SDK, the MCP server, the decision contracts predicate engine. All of it. Aurora is one of 2 products under FantasyLab.ai. Aurora handles glassbox quantitative intelligence. Fantasy Studio handles cinematic 3D rendering with real physics. 2 surfaces, 1 philosophy, AI that shows its work and runs on your machine. If you found this useful, drop a like, hit subscribe, and consider supporting the build on Patreon or starring the repo on GitHub. The install command is on screen. 5 lines, 60 seconds. You're running a verified quantitative Cortex on your own laptop. Visit FantasyLab.ai for both products. Open source, local first, glassbox, 0 fabricated. Thanks for watching. Everything's at github.com/fantasylab/Aurora. Next video, I'll show you how to wire Aurora's SDK and MCP server into your own Python projects and AI agents. See you there.